we're already familiar with how to work with square roots, but we can also work with other roots, third roots, fourth roots, really any root we want to. We call them n roots. So let's take a look at our first example. It's the square root of 16. Now, we never write the little invisible number like you see on these other examples, but with a square root there's really an invisible 2 right there. What we're asked to do, well, we know the square root of 16 is 4, but the reason that's true is because we're looking for two numbers that multiply together to equal 16. So the reason the square root of 16 is 4 is because 4 times 4 is equal to 16. We'll use a similar thinking for working with other roots. So for example, when we take a third root, or we'd call it a cube root, we're looking for three numbers that multiply together, the same three numbers, to equal the number inside that radical symbol. So three numbers that multiply together to equal 27, that is going to be 3. And again, you could get that by guess and check, you could work that out, but really it boils down to the reason the cube root of 27 is 3 is because 3 times 3 times 3 is equal to 27. Now, all the examples on this screen are going to work out to be integers, so you can get them by guess and check. Hopefully you have some of these memorized as well. If you want to see how to do these on the calculator, go ahead and skip to the end of the video. I'll show you how to do cube roots, fourth roots, fifth roots, etc. on your calculator. So go ahead and skip to the end if you want to see that. Next up, we have the fourth root of 81. That's asking us to find four numbers that multiply together to equal 81. Well, obviously it has to be a small number, and again, you can try guess and check. You can try doing 2 times 2 times 2 times 2, 3 times 3 times 3 times 3. Eventually, you're going to find out that 3 is your answer again, because if I multiply 3 by itself 4 times, or raise 3 to the 4th power, that's equal to 81. Okay. The next column of problems, notice the difference is the number inside the radical symbol is a negative number. So let's go ahead and take a look and see what happens when we're working with negative roots. So again, I have the square root of negative 100. Well, we learned a few units ago that we can't do the square root of a negative number and get a real answer. So I'm going to just say that for this. There's no real solution, no real answer to this. However, we did learn about imaginary numbers, and so we know, hopefully, that the square root of negative 100 is just 10i. But for this unit, we're going to stick with just real answers. Again, the reason that there is no real answer for a square root of negative 100 is I can't multiply two of the same numbers together to equal negative 100. If I try doing negative 10 times negative 10, that's positive 100. That's not what I want. If I try doing 10 times 10, obviously that's 100. So some people say, well, what about negative 10 times positive 10? That would be negative 100. True, but then notice I'm not multiplying the same two numbers together, so that doesn't count as a square root. So that's why we can't do a square root of a negative number. How about doing a cube root of a negative number, though? Can you think of three numbers that multiply together to equal negative 64? You can try that on your calculator, or again, skip to the end of the video if you want to see how to do that. But it turns out that there is a solution, a real solution. It's negative 4. I can multiply negative 4 times itself 3 times and still end up with a negative number. 3 negatives would multiply to equal a negative product. So that actually works out to be a real number. The fifth root of negative 32, again, you can try some guess and check or use your calculator. That comes out to be negative 2. And basically the pattern that we noticed in class here was that anytime the root you're doing is an odd root, like a third root or a fifth root, it's okay to do that for a negative number, because multiplying a negative number times itself an odd number of times will get you a negative answer. You can't do it for something even. So square roots or fourth roots of a negative number won't give you a real solution, but odd roots will. And then finally, real quick, I just have an n there because it could stand for any integer we want it to bigger than 1. So any root of 0 is just going to be 0, because multiplying 0 times itself any number of times will always result in an answer of 0. So that's just what we wanted to talk about real quick with negative numbers and odd roots and even roots and all that. If you want to see how to do this on your calculator, let's take a look at how to do that right now.